So we are continuing this previous lesson where we are talking about the factors affecting the capacitance of a periplate capacitor, and we said there are majorly three factors, that is permittivity of a medium, cross-sectional area, and then the distance of separation. When you are explaining one of the factors, for example area, then the other two factors must remain what? Must remain constant. For example, when I have now a plate like this may be my plate X, and then this is my plate and plate Y. So this plate X is going to be earthed, so it remains neutral, and then plate Y is going to be given a positive charge and then connected to the cap of a gold leaf electroscope. So that is that. So plate X is made neutral by connecting it, by earthing it, and then plate Y is made positively charged. When you make it positively charged, you connect it to a neutral gold leaf electroscope, and we shall see the gold leaf diverging. So now I want to test any of these three factors affecting capacitance of a capacitor. You know that increase in distance leads to a decrease in capacitance of a capacitor, since capacitance and distance are inversely proportional. Then permittivity and area are directly proportional to capacitance of a periplate capacitor. So when you look at this experiment here, those are the conditions. One of the plates is made neutral. 2, the other plate is made what? Positively charged and connected to a neutral gold leaf electroscope. If it's connected to a neutral gold leaf electroscope, then the positive charge will flow, and then the leaf divergence is seen, or the leaf is seen to diverge. Now I want to now explain distance. For distance, now I now vary the distance between the plates. I'm going to now say plate Y is moved away from plate X, whereas keeping area of overlap constant. See, plate X and plate Y is moved away, so you are going to move it away like this. You are moving it away like this, but do not alter the area. We are keeping area constant. When I move like this, do not move it up like this. Area of overlap means that the area which is actually facing this, so I'm going to move it along a straight line in that way. So when I move it like that, I'm increasing the distance. Then as I move it like this, I keep on noticing the divergence of the gold leaf. When I move it away like that, the gold leaf is seen to what? The divergence of the gold leaf is seen to increase. So when the divergence of the gold leaf is increasing, it means that the divergence angle increases, and angle divergence is directly proportional to the PD. And you better know that C is equal to Q over V. So if V increases, C decreases, and therefore distance is going to increase in distance will lead to a decrease in capacitance of a capacitor. I repeat, for distance, I'm going to vary by moving one plate away from the other, but making the area of overlap constant. When I move one plate of the capacitor away, you realize that the divergence of the gold leaf is seen to increase. When divergence increases, the PD also increases, since PD is directly proportional to the angle of divergence. And therefore from C is equal to Q of V, as V increases, C decreases. Now take for example so the area of contact. If I want to reduce the area of contact, then I have to move this plate slightly up or slightly down. So but I don't alter the distance of separation. Initially, of course, when I make this one neutral, this one positive, and according to the neutral gold leaf electroscope, the divergence of the leaf is noted. Then now I vary the factor. How do I now vary the factor of area? By moving plate y upwards, keeping the distance of separation constant. You realize that also the divergence is seen to increase. When the divergence increases, the PD decreases. When the PD decreases, capacitance does what? Increases. So, but what do? We reduce the area of contact. Because when I move it up like this, you see, the area of overlap goes on decreasing. But when they are like this, you see this area overlap is large. But when I keep on moving it up like this, maybe it is currently at this position. Maybe it is currently like this. You realize that the area of contact decreases. So when I move it up, the area will decrease. So we expect the capacitance to decrease. So when I move it up, I now keep on noting the leaf divergence. We realize that practically the divergence of the leaf is seen to increase. So when the divergence of the leaf increases, it means that the PD also does what? Increases. But increase in PD leads to a decrease in capacitance of a capacitor. Then finally, we look at the permittivity of a medium. So initially, I'm going to leave this into the, of course, I first solve the initial conditions. One of the X is made neutral, Y is made what? Positive. Connected to a neutral Godly spectroscope, I notice the divergence. Then from there, now I want to test the factor of permittivity. To test for the factor of permittivity, initially, I'm going to have those initial conditions. Then I will notice the leaf divergence. Then from there, I now insert a dielectric material inside. A dielectric material is any conductor, is an insulator which breaks when the PD is high. We shall look at that definition when we proceed. So I press the dielectric in between the capacitor plates. When I press the dielectric in between the capacitor plates, you realize that the divergence decreases. The divergence decreases. When the divergence decreases, it means that the PD decreases. When the PD decreases, it means that the C increases. And that is all. So when C increases, it means that literally the permittivity increases. And that is why permittivity and air like proportion to C, which C is inversely proportional to D. So generally, when I'm to explain those factors, I have to first of all mention the initial conditions of the apparatus arrangement. Initial conditions of the apparatus arrangement. For example, for this case, X is made what? Neutral by earthing it. Y is made positive, connecting it to this Godly electroscope. Then I notice the divergence. Still here I have to notice the leaf divergence. I notice the leaf diver. Don't again say the leaf is seen to increase in divergence. No, initially it had collapsed, but when I connected the possibly charged plate, I have to just take the what? See the angle of deflection. Now secondly, I now vary the factor. And now when varying the factor, you have now to check on the degree of divergence. Degree of divergence from the original. Does it increase or decrease? Then from there you relate theta to PD, then PD to what? To C. How? You know that theta is actually proportional to V, and also C is equal to Q over V, and you will be exhausting all the factors affecting what? The capacitance of appropriate capacitor. Some questions they can ask you to illustrate all the three factors, so you have to mention one by one in particular.